Welcome. Today we are going to look at the histological organization of the pituitary gland. The pituitary gland is also known as the hypophysis cerebri. The hypophysis cerebri. So histologically, it has two parts, as you can see even from this diagram. That is from there up to there. This is the adenohypophysis. Then this other part is the neurohypophysis. So the adenohypophysis has three parts: pars distalis, pars intermedia, and pars tuberalis. So maybe I have the this is the pars intermedia. Pars intermedia. So the pars intermedia is this part. If I go in higher magnification will show you such things. This is the a protein-filled cyst colloid. This is like a colloid. Remember the colloids we also saw in the thyroid gland. So the pars intermedia is one of the parts. So the pars distalis is located to anterior to the intraglandular cleft. In this our slide is a transverse section, so it cannot show you the position of the intraglandular cleft. So anterior to the intraglandular cleft is the pars distalis. Posterior to the intraglandular cleft is the pars intermedia, and the pars tuberalis is located around the infundibulum. Remember, the infundibulum is the one which connects the pituitary to the hypothalamus. So let's look at the cell types. I think the cell types is the one which will help you the most. So let's start with the cell types of the neurohypophysis. So the neurohypophysis, the cell types are usually classified the neurohypophysis. Let's look at the cell types. One cell type, the cell types in the neurohypophysis are the pituicytes. Okay, the neurohypophysis has pituicytes. So maybe I should have said the parts of the neurohypophysis as I had said for the adenohypophysis. The cell types of the parts of the neurohypophysis, include the median eminence, pars nervosa, and the infundibular stalk. So we have those. So I want you to let me show you the whole slide again, then we do a magnification. So this is the whole slide. This is the adenohypophysis. This is the neurohypophysis. Let's go in at some magnification, say 10x. I want you to see, you can agree with me that this is the adenohypophysis from, you can see from here. This is the adenohypophysis here. You can see it is mainly cellular, okay? But if I go posteriorly to the neurohypophysis, you can concur with me that this is like we have fibers here, okay? So these fibers are the axons of the cell bodies, which are usually axons of cell bodies which are usually located in the paraventricular and the supraoptic nuclei in the hypothalamus. So the axon usually terminate here in the neurohypophysis, okay? So, and the axons, at the terminal end of the axon, they have a gyration. Those gyrations are known as the herring bodies. herring bodies. Herring body. Let me show you a one herring body. This is a herring body. A herring body is simply a direction of the terminal end of the axon, a neuronal axon, whose cell body lies either in the supraoptic or paraventricular nuclei. So remember, the supraoptic and paraventricular nuclei usually produce two hormones, oxytocin and antidiuretic hormone. I want you to go and thoroughly do research. Which hormone produces, from which cell nuclei, from which nuclei do each hormone is produced from? Is oxytocin produced from paraventricular? Is ADH or vasopressin produced from supraoptic? I want you to write in the comments section if you can. So these are the herring bodies. Then you can see these nuclei. Those are the nuclei of the pituicytes. Okay. So from the hypothalamus to the neurohypophysis of the hypophysis cerebri, we have a tract known as the hypothalamo-hypophyseal tract. It is the one which usually now carries the hormones produced in the hypothalamus to the neurohypophysis of the pituitary gland or the hypophysis cerebri. So then those hormones are usually stored in the herring bodies, awaiting to be where, when under stimulation, they are usually released into the bloodstream. Remember the function of oxytocin during labor, and also the function of ADH, vasopressin, which usually control the amount of water that has been reabsorbed in the renal tubules. So oxytocin, it usually acts on either the myometrium, causing uterine contraction during birth, and also can target the breast myoepithelial cells for milk secretion. So vasopressin, I've said, is for renal water reabsorption controls, and oxytocin acts on the myometrium and the breast myoepithelial cells. So that is all I can say of the neurohypophysis. Remember the parts: a median eminence, has also a pars nervosa, and the infundibular stalk. Those parts I cannot illustrate from this part, but you can use your atlases to see those parts. Then let's look at the anterior pituitary, or the anterior pituitary lobe is what is known as adenohypophysis. I've said it is, if you look at it, it is cellular. So the adenohypophysis usually secrete tropic hormones or releasing stimulating hormones, tropic hormones. So the cell types, they are usually classified according to their ability to take up dye. This is the H and E stain we have used in this slide. So the ones which take up stain are, or the dye, they are called the chromophores, and they are the ones which usually produce hormones. Chromophores produce hormones. Chromophobes, let me show you the spelling of a chromophobes. These chromophobes do not produce hormones. Let me show you. And they do not take up the stain. They don't take up the stain. They don't produce any hormone. They are just there. So these ones which are not taking up the stain are the chromophobes. Here you can see sinusoidal capillary there. Let's look at the chromophores. Chromophores, they take up the stains. So they are of two types. There are these one which are taking up the stain and becoming somewhat purple. Then There are these other ones which are taking up the stain and becoming somehow, I say, red. Okay. So, acidophils. Acidophils are the one which take up the stain and become this color. Don't know if I call it red. Looks to me like red or pink somehow. So acidophils are of two types: somatotrophs and the mammotrophs stroke lactotrophs. I have some notes here I can show you. Acidophils, they are, yes, pinkish red with H&E. Somatotrophs, they produce the growth hormone. Mammotrophs produce prolactin. I want you to go and investigate the function of each and every hormone I will say in this session. Then we have the basophils. They stain bluish purple. These ones, bluish purple. Let me make this larger again. Bluish purple. Then the basophils are of three types. We have thyrotrophs, corticotrophs, and gonadotrophs. So thyrotrophs produce thyrotropin hormone, or what is known as the thyroid stimulating hormone. Corticotrophs produce corticotropin hormone, or the adrenocorticotropin hormone. Remember, the adrenocorticotropin hormone usually act on which layer of the adrenal cortex? Is it the zona fasciculata? Zona fasciculata. If you haven't seen my video on the histological organization of the adrenal gland, you should view it. It's a very good one. We also have the gonadotrophs. Gonadotrophs usually produce gonadotropin hormones such as follicle stimulating hormone and the luteinizing hormone. So it is very hard to distinguish which is which. So just know these are the these are the basophils. The basophils. Then the red staining one, let me show you, those are the basophils, pinkish, blue pinkish, somehow like that. And acidophils, remember they were two. These ones, the acidophils were either lactotrophs or somatotrophs. Somatotrophs produce growth hormone, lactotrophs produce prolactin. Good. Let's so remember the parts of the, as I had told you, of the adenohypophysis. We had pars distalis. Pars distalis, in fact, is the one which we were looking in. It has those cell types. The pars distalis is the one which has the chromophils and the chromophobes. The chromophils are either acidophils or basophils. Then we had pars tuberalis, not shown here. Then pars intermedia, I told you, is the one which lies posterior to the intraglandular cleft, a remnant of the Latke's pouch. You see, at the interface between anterior and posterior lobes that contains numerous colloid filled cysts. So let me show you a colloid filled cyst, like this one. This is a colloid filled cyst. Remember, pars intermedia, it produces only one hormone. And I think this question is very challenging. We have ever been asked here at the university. Pars intermedia produce melanin stimulating hormone. Melanin stimulating hormone is the one which is responsible for pigmentation. Yeah, pigmentation of the skin, if I might say. So you can imagine if you have say a tumor in the pars intermedia, which now causes overproduction of the melanin stimulating hormone, you will have hyperpigmentation of the skin. So they had looked at the posterior pituitary, is now what I was calling the neurohypophysis. Axons from the hypothalamus that release hormones to the capillary. Then I showed you the pituicytes, those nuclei. Pituicytes are glial cells, supporting cells of the nervous system. Like this is the nuclei of the pituicytes. Then I showed you a herring body. Let's see a herring body. Herring body. Herring body, I said, is a direction of the terminal end of the axons, which usually now store the hormones. And then it is filled with the neurosecretion vesicles. Those neurosecretion vesicles contain the hormones, oxytocin and the ADH, and then antidiuretic hormone or vasopressin. Okay, so remember anterior pituitary. Let's go back to anterior pituitary. Remember, anterior pituitary is its function are usually controlled by the hypothalamus via the hypothalamo-hypophyseal. Now this is not tract but a portal system. We have portal blood vessels, a portal vein. So this portal vein, what is a portal vein? A portal vein is a vein which has capillaries on both ends. So the primary capillary plexus is usually contained in is found in the hypothalamus, and the secondary capillary plexus is the one which is found in the adenohypophysis. So the hypothalamus usually produces the releasing or inhibiting hormone. Let's say we have a releasing hormone is produced in the hypothalamus, then it enters the blood at the primary capillary plexus, then via the portal vein, it reaches the it will reach the adenohypophysis, where it will stimulate the chromophobes to produce the hormones. So I can show you sinusoidal capillaries. Sinusoidal capillaries are these ones. See, it is highly vascularized. They are the one which now usually transport the hormones to the other parts of the body. So with that, I have come to the end of this session. Remember, pituitary gland has adenohypophysis and neurohypophysis. Adenohypophysis has 3 parts: pars distalis, pars intermedia, and the pars tuberalis. Neurohypophysis also 3 parts: median eminence, pars nervosa, infundibular stalk. Remember the cell types of the neurohypophysis: pituicytes and has herring bodies. Then remember the adenohypophysis has 2, as I think I should say this. I'll show you the notes. Anterior pituitary, or what I'm calling the adenohypophysis, has chromophils and chromophobes. Chromophils, they take up the stain. Chromophobes do not take up the stain. And I said chromophobes don't take up the stain, don't produce any hormone. These ones. Chromophils take up the stain, and they take up the stain in 2 ways. Can be like this: bluish purple. Those are basophils. 3 types: corticotrophs, thyrotrophs, gonadotrophs. Acidophils, pinkish red. They take up the stain and become pinkish red, HNE. These ones, 2 types: mammotrophs or the ractotrophs and the somatotrophs. So with that, I've come to the end. So thank you and subscribe for more.